Okay, so moving on. So another reason that we wanted to understand distributions is we want to use them as the more that we understand our distribution, we can get a sense of really where or what we would define as an outlier, where it would start, what we could well, where we would define what the starting point is. An outlier in exponential distribution might look very different than an outlier in a normal distribution. So we use this to help us define the shape of the distribution, to help us define really where it starts at the threshold of where we would say this is now. Okay. We also want to understand the skewness and the curtness, leaning one side to the other side. Is it really skinny or is it really fat? We want to understand the shape of our distribution. These will play into the statistics. If it has a skew one way and a long right or left-hand tail, we want to understand that that is going to be affecting very significantly in that case something like an average, right? And so maybe in those situations we want to, now that we know that the shape of our distribution has a skew and it's a little bit off to one side and a long right tail on the other side, we want to be using a median instead of, or maybe the mode instead of the average, right? So these are little simple things, but we really want to understand the shape of our distribution and define it really in skewness or kurtosis. One of the things that I like to do when I get started with my data analysis, I like to plot lots of the distributions, not necessarily to look at them side by side, but this is something that happens is as you start to understand the distributions, you can see, are there similar patterns happening in each one? Is this repeating over and over again? If you were to see one exponential distribution, yeah, it's not a big deal, but as you start to see lots of them, you can almost be sure that that would be a financial data set. That's my background, and financial exponential distributions are not my favorite now. Truthfully, I used to just they were everywhere in finance, but it's one of those things that exponential distributions been really noticing that you see them a lot. So that pattern can give you a lot of sense about what you'd be expecting from other distributions as well. If you notice things, you're expecting these patterns, these things are all looking similar. Are the same patterns repeating, right? Or are they not repeating? Both of those can be very enlightening and help guide our analysis of it. Okay, so to help us remember these points is, when was the last time you saw the moon? You remember, where were you? Were you out with a friend, or were you out with at your family's house? Me, the last time I saw the moon is I was just outside my apartment actually, and I saw the nice big moon up in the sky. And really think about that moon, and all of a sudden you notice as you're looking up at that moon, data is falling down. Kind of weird, huh? And we know that's outlier data because, well, that doesn't really happen often. It's really going to help us remember that we want to understand our outlier data. We want to define that threshold. I said that was outlier data, right? So I define my threshold when data is falling from the moon. Call that outlier data, right? So that's really where it starts. Maybe not surprising that that's where we would define our outlier data. We also want to understand as the data was falling down, our vision started to get skewed and a little bit blurred, and we kind of were wondering really, are we seeing things correctly now? Could we maybe not be interpreting the world around us in the correct way? And as we see our friend, a good old friend that we've had for a long time, starts walking up to us, and well, we got to get a little bit concerned then because our vision's a little bit skewed. We're not really seeing, we're not interpreting the world correctly. And so we're kind of concerned that this skewness and this kurtosis could be affecting our future relationships, our relationships with our friend who's walking up to us. Data is falling down from the sky. Our friend is walking over to us, and well, this data is really making things, or the skewness, this outlier data is really affecting the way that we're seeing the world. And so we just need to be conscious of that and make sure that we're presenting our summary statistics in the correct way. We're being as clear as possible in light of imperfect distributions.